number of islands. The question is, give you 2D grid, it's a binary grid. 0 is island, no, 1 is island, 0 is water. We need to find how many islands in this grid. So for example, here 1 is all connected together, it should be only 1. And here is 1 island here, 1 island here, 1 island here. So it's 3. First, I use a DFS. We first, to check if the grid is null or the length is 0, we return 0. And then we try to get the count. Count will be the total islands number. So first we initialize count equals 0. M is the row, N is the column. We do the for loop, and once we find the grid equals 1, which means if we find 1 island, we do the DFS. And in the DFS here, this is the row and the column. We see if row or column smaller than 0 or row and column bigger than the row and the column boundary. So these 4 is to out of boundary, and if the point here is equals to 0, which means this is no island, we need a return. So this is the base case for the recursion. And then we let 0 equals this grid, so as marked as visited. So next time if it is the 1 changed to 0, it will be not calculated again. Same we do the recursion rule by the 4 directions. After that, we get the islands. If everything is connected with the first 1, we will count 1. Then we do the for loop. If we find any 1 again, it means there's another island exist, and we do the DFS to see if there's any 1 connected with that 1. This is a DFS function. The time complexity and the space complexity are both OMN, because MN are row and column. In the time complexity, we do the for loop and the for loop here. And for the space complexity, we need to store all the heaps when we do that. And the next, I use BFS. So the logic are kind of same here. If the base case is null, we return 0. And then we generate count, row and column, SM and N. The difference is we have a queue to store the status. Here are also the same, except once we find the 0 means, no, once we find the 1 means we find the island. We change the island to 0, it's also like visited. Then we store this point to the queue, and in the queue we do the BFS. We are trying to find any connections with this island. So when we do the BFS here, we generate 4 directions: left, right, up and down. Then if the queue is not empty, we pull the first point and we plus the matrix, like direction 0 will be this one, because in this for loop here, so directions, the first one is 1 0, and the direction 0 is 1 plus the point 0. What's point? Point is the first queue elements we pop up, and the point 0 will be the left side of this grid, and the C is the row, and the C is the column of this one. So same here, direction 1 will be 0, point 1 will be in the queue is the J here. Then we traverse all the different directions in the for loop, and if they are out of boundary or the grid is equal to not island, we continue search. Once we find anything is 1, we generate it to 0. It means it's connected and we mark as visited. Then we put this into the new queue, because it's only generate left, right, up and down. If we find the left, we need to add them in the queue and find the left one if there's anything connected. So this is the BFS. Once everything is found in the grid, we count +1. We need to put this after BFS, because if we put before the BFS, it will be count the whole island after do the BFS. So since we set all BFS to 0, then we need to add. If we put let me explain again. If we put the count +1 before the BFS, so then the first time we add 1, and then BFS find everything. Let me see if it works or not here. Let's see here. Okay, so let's run the code. Oh, it also works, so it doesn't matter. I'm sorry, it doesn't matter. It can be both way. Doesn't influence anything. And the time complexity and the space complexity are also OMN. There's another way to solve this problem is by using unified. I will study later.